Thanks, Johan. Hi to everyone. Hi, thanks to Seth and Marcelo, Johan, Jan for inviting us and share our experience with you. We'll talk about a bit Argentinian production model, our main issues we have under no-tilling, and challenges for the future. So we'll make a brief introduction of actual Argentinian productive systems. What is the No-Till Farmers Association? We'll talk about the pillars of the no-till systems, how are we going with that, the main benefits we see of these systems, and some issues and challenges we have to get through. So at first, for context, Argentina has about 35 million hectares of productive land. We mainly produce soybean, maize, and wheat. These are our main extensive crops. We have a very diverse territory with about 2,000 kilometers long. We produce mainly under rain-fed conditions. We have very deep and salt and fertile soils through our country, and we have high variability in environmental conditions and also in socioeconomic conditions. We including high tax burden and significant leased land. About 70% of Argentinian production is done in leased lands. So we have to manage under no-till under these conditions. So what is APRESID? APRESID is an NGO organization composed by farmers and advisors too, that aims to promote sustainable productive systems of food, fiber, and energy. And we want to optimize that production, taking care of the environment. And also doing this, promoting innovation in networks. This is our scope. So for who are not agronomists or farmers, a brief description of what is a crop cycle. A crop cycle starts with the harvest of the previous crop, then the sowing of the crop, management of adversities and crop nutrition, and at the end we harvest the crop. So no-till farming changes the dynamic of each one of these processes and what we have to do to be successful under no-tilling. So we'll talk a bit about this over the lecture. The no-till system. The pillar of the no-till systems are three, we believe. The first, to get the stubble over the soil surface. That's one of the main points. The second point is not removing the soil surface. That's a big difference between common agriculture. And the third is to promote biological activity in our soils. So how we do this? With different practices. The first one is no-tilling. No-tilling is about not plowing the soil, drilling without removing the soil, but this must not be a lonely practice. It must be combined with another ones. This is to have living crops all through the year as water from rains allow, to have diverse landscapes. This is to have crop rotations over the years in the same field, and do ecological nutrients and pest management in our fields. So it's important to remark that this is a system, not an isolated practice, just no-tilling and that's all. So, and these practices must be consistently applied over time. It's very important, this point. These systems involve a beginning when we start with low soil organic carbon and nutrient cycling, and we get through the year to different stations of transitions, consolidation, and maintenance of these systems. So at least when the system is mature, we get high biological activities and nutrient cycling. We have to replace the effect of plowing with roots and biological activity. So that's it. How we're going with these different pillars we have to apply in our system to be successful. In Argentina, no-till has raised up since the beginning of the 90s. Nowadays, we have about 90%, 85% of Argentinian surface under no-till. So we have adopted this practice of no drilling or no-tilling the soils. Also, many countries in South America has taken this way. This demonstrates not just the agronomic viability of the system at research stations, but also its economical benefits for farmers. Farmers wouldn't do something that is not profitable for them. So the system has brought benefit to them in this sense. So how about living and diverse landscapes? Argentina at previous 1975 the agriculture was mainly based on grasses, on cereals like wheat and corn mainly, or maize. At 1975, soybean crop was introduced in Argentina and started growing up slowly in surface. At about 1985, 1990, no-till started to be applied by a small number of farmers in Argentina. One of them founded our institution. Our institution was founded in 1989. And then there was a continuous increase in agriculture area and in soybean area as first crop. But in the last 10 years, we have experienced a decrease in soybean as first crop, with gains in surface in winter cereals as wheat and rye and barley, and in maize too. So in this sense, we are not as we want to be, but we are getting better than 10 years ago nowadays. About crop nutrition, we have in these last 2 decades, we have increased in nutrients reposition, talking about phosphorus and nitrogen. We are getting better, but nowadays we are not giving the soil everything that crops takes out, especially in some regions like North Argentina, where we still have very fertile soils, and farmers usually do not fertilize much. And in terms of sulfur is it's a bit lower the reposition levels we have. We get back on the soil about 30% of the sulfur we take out. And in terms of potassium, we don't fertilize with potassium nowadays. We have very rich soils, but I think not too long we'll start seeing yield response to this nutrient. In terms of pest management, we have risen up the number of liters per hectare applied since 2000 till a decade from now, and this has stabilized or a little decrease. But if we talk about liters of herbicides, fungicides, insecticides applied per ton product, per ton of grain produced, we have a stable value that hasn't changed much through the years. So because systems were more productive for each surface unit. And in terms of the quality of these products used, we have a high number of, we classify in Argentina, we classify these products in toxicological classes. We have greens, blues, yellows, and reds. Greens are the best, it's class 4. So in terms of herbicides, we have many of our products are 3 or 4. Insecticides, we have companies have to develop more insecticides of 3 or 4 bands, and fungicides are quite similar like herbicides. So there is a point that advisors and farmers have know better these products and use more of bands 4, we believe. The no-till system benefits. I'll talk about some specifically. A big problem in Argentina was soil erosion by water erosion and by wind erosion. This is southern Buenos Aires province, a region that still nowadays we have many farmers who nowadays plow or disc their soils. And for example, this is a wind erosion image that all our earth is going through the land, our soil, through the sea, sorry. And no-till in Argentina led our country to be a leader in soil erosion reduction over the years, such as many countries that adopted no-tilling. Another big benefit of this system is that the reduce of the machinery traffic in the fields. This takes our fields our farmers to reduce fuel use. This is one of the benefits we talk about with German farmers we visited these days. They saw the same. We have greater sowing opportunities because we preserve water in our soils. It allows double cropping. This is very important for intensification. With no-tilling, we became able to do wheat and soybean, for example, or wheat and corn in the same growing season. That was very important for our systems. Farmers have more time, so sometimes they can increase their productive surface, and no-tilling allowed to increase productive land in Argentina. Some marginal lands became changed to agriculture because it made possible to produce in these fields. No-till, as I said, allows more intensification of our rotation. This is an example of no-tilling of soybean after wheat in the same growing season. Nowadays, we are going a step in front. We are broadcasting cover crops, so over leaf crops, for example, with planes, drones, and other machinery. And also, when the water conditions are favorable, we can do planting green of grain crops, such as maize, over cover crops. This is what yesterday we saw some farmers here that are doing this in their fields. So another big benefit of no-tilling we see is that it has water water availability. For each millimeter of rainfall, we can catch more of this. That we call effective rainfall. If we are under no-till, then rather than we are on conventional tillage. This is an old work done in our country. But also under no-till, it's not the same if we have a bare fallow, no crops living in the soil when a rain comes, or if we have a cover crop or a wheat crop, for example. We can catch more of this rainfall if we have a leaf crop rather than when the soil is bare with no cover. This is one of the main reasons that because of we can go to produce in marginal lands there. No-till increases soil organic carbon also. The best situation is a pasture when we have all the days of the year, getting the sunlight in our soils, the carbon in our soils. But when we do agriculture, this is not possible. But we see that with no tilling, we can decrease less in soil organic carbon and stabilize soil organic carbon in higher levels than in conventional tillage. This is also work from the beginning of this century in Argentina. And this is a recent work done in Brazil, also in comparing native vegetation with plough-based systems and no-tilling systems. They see that in plough systems, the carbon losses went through 30% to 35% of the soil organic carbon at 1 meter depth. And when they apply the no-till system, they can increase soil organic carbon from 44 to 65 tons per hectare at 1 meter depth on average. So this is a great benefit. Also, we see under no-till, it's not the same to have a low intensification of the crop rotation, number of crops or living crops over the year, rather than have perhaps 2 crops every year. So this increases soil biological activity in terms of microorganisms, also mesofauna in our systems. And we need these organisms, micro and mesoorganisms, to do what plowing or disking did in the past. So we need them in our soils. Also, no-till reduces CO2 emissions, soil emissions, compared to conventional tillage systems. This is an article from another country. And with groups of farmers, we are working on this. We saw that when these are different fields where we work, and we see that when we do crop rotations with more living crops, we get more efficiency of grain produced by unit of GHG gases emitted. So now we'll talk about some issues that we have. First, we will talk about some main problems we have when farmers do not apply the no-till system, just no-till. That's right. This is, for example, when they do no-till, but they do soybean monoculture, for example. That it's an example of what I am talking. In our country, we have nowadays a situation that we have increased number of weed resistance registers since the 2005 thing, and nowadays we have about 50 registered resistances in different weeds and modes of actions of herbicides. But we are working with those group of with some group of farmers, and there are solutions in the no-till systems not to get out of it and get back to plowing. We see that when we intensificate our crop rotations, we are able to reduce at the half the numbers of applications done in the fields. Also, for example, this is an example of how a field looks when sowing maize over a cover crop. We can reach sometimes no applications when we do this in our fields. So we believe there is a huge gap to increase our management through Argentina. Also, selective applications. We have new technologies that allow us to do selective applications on our fields and reduce 80% of the herbicides, for example, applied in our fields. This is a problem. Another big problem is the soil compaction or soil densification. This is are images of a field where we are working. All these situations are under no-till. The difference is made by the crop rotation we use, for example. This is soybean monoculture, when you have a very compacted soil with layers, with horizontal layers that do not allow water infiltrating the soil. But when we start doing better crop rotations with 2 crops over the year, combining grasses and legumes in the rotation, and also some cases we include pastures as a highest level of intensification, we get improves in our soils. Also, traffic control is the control of traffic of the machinery in the fields is a very useful practice to manage this problem. Some German farmers we visited were doing this in their fields nowadays. And there are also issues specific when we apply this system. When we apply this system, we raise up the stable levels in our soils, and this, for example, higher the risk. We have higher risk of frosts. We can deal with this managing sowing dates, using specific genotypes resistant to frost, crop nutrition, the partial use of the stubble for forage. That's integration with beef production is useful to manage this. Another problem we have is the non-uniform emergence of our crops. We have solutions to uniform the distribution of the stubble. With spreaders in the harvest machine. We can use residue sweepers, planting speed, planting depth. We can manage the crop rotation, such as not to get high amounts of stubble in our soils. So there are solutions in the system to get through these issues. And another point is we work with nature. When we change something, the nature go through, and when we change the system, appeared some, for example, new pests such as slugs or good lice. They like humid environments, so we have to manage this with proper distribution of the residues, early monitoring of this, for example, the slugs, specifically when we have many water in the soils, cold environments, control when necessary. We have a huge gap to explore, talking about beneficial organism and natural control of insects and fungi, and reduce straw and stubble in the fields by grazing, for example, forage, or bioeconomic uses, like biomaterials, bioenergy, for example. About our strategic challenges of Argentinian production and proceed also. One of the main points to look ahead is we have to increase the no-till system adoption. This is all pillars simultaneously. This is our goal. So we think we must demonstrate the farmers that in addition to the productive and environmental benefits we see, there are economic advantages of the whole system implementation. This is because economic factors are mainly the main drivers, sometimes the main drivers of the adoption of farmer technologies. So we think we have to do work to communicate better the impact of the whole no-till system implementation. We have to improve the communication of the principles and benefits of the no-till system to farmers and the society as a whole. APRESID has different programs of group of farmers taking APRESID voice in their regions. We have an international program. There we work sharing our vision, our productive systems with other countries. And we have an annual big congress in Argentina where all these topics are. We have lectures about all these topics every year. Another important point is to have a participatory systems of research, knowledge transfer, innovation, but it's important that they must be led by farmers. The farmers had to lead their own development with scientific support, obviously. So, for example, in APRESID, we have a chakra system program. This is an alliance between APRESID and INTA, which is the National Research of Agriculture Institute in our country. It's a methodology to develop solutions to farmers' problems or needs with scientific support in their productive systems, in their environmental conditions. So we develop projects based on farmers' demands. We promote horizontal protagonism, where farmer researchers, the private sector, the state work together with the farmer, leading all the process. And the other point is learn by farming. We build knowledge on farmers' fields, and in this process, we try to train specialized human resources on farmers' demands on their regions. Another big challenge is how to decouple production and environmental impact of our system. We think we have to go through this. We have many tools nowadays with new technologies that we think we can do it much better than we are doing now. This is not just for Argentina. I think about the whole world is in this way. And also we must develop bioeconomy and added value to our productive systems. Not just producing grains and exporting. We have to be more industrialized in this sense, I think, to get better. So to conclude, Argentina, we are in Argentina's no-till journey has some success, and it's a work in progress situation. We have scaled up our system in terms of no-tilling, but we had to add quality to this to get a real no-till system implemented all through Argentina. So we had to have full adoption of the system, share our learnings, and improve resilience of our systems. Um, there are global challenges nowadays to face demands, and we believe that these solutions must be systemic, but must be science-based and mainly led by farmers who in our institution are who implement the solutions in their fields. And in APRESID, we believe that the no-till system is part of the solutions for our global challenges. So many thanks for you for being here with us, the people who is following this speak online. And now Hernan and I will ask the questions you have for us. Thank you very much.